Special product. So this is our continuation of our discussion previously about special products. So in case if you don't remember, instead of using the long multiplication procedure through distributive property, we can obtain products of certain cases. That's why they're so called as special products. So this time, what we will look into would be two binomials with commonality. So as you can see, the first terms are the same. And the second terms are also the same except the sign in between or the operation, let's say operation, plus or minus. So when we do the traditional way, so what we usually follow, we multiply the first term of our first binomial to our second binomial. So that's a times the quantity of a minus b. Then we multiply the second term of our first binomial to the second binomial. So b times the quantity of a minus b. And we distribute. So a times a squared. Then a times negative b is negative ab. Then b times a, you'll get ab. B times negative b is negative b squared. And then we combine like terms. So negative ab plus ab are like terms. But this is negative 1 plus 1. That makes it a 0. In other words, that would just be a squared minus b squared. How about if we interchange the two? A minus b comes first, and then a plus b would be our second binomial. So same concept, first term is a multiplied to our second binomial. Second term of our first binomial, that's minus b, and then multiplied to our second binomial a plus b. So a times a times b is a squared plus ab. Negative b times a is negative ab. The negative b times b is negative b squared. And then same thing happened. ab minus ab is just 0. So you're left with a squared minus b squared. That will give us the second shortcut or second special product, which is so-called as the product of the sum and difference of binomials. So why is it so-called as sum and difference? Because the only difference that they have would just be the operation plus and minus. And what is the shortcut? Just get the square of our first term, a squared, and then it's always a minus in the middle, and then the square of our last term. Then you'll get the answer. So to better understand the process, let's have an example. Okay, by the way, our result, for you to easily remember how to do it, you can think of a result which is the difference of the two squares. It's so called as difference because it's always minus, and then two squares because the first term is a perfect square, and then the second term is also a perfect square. So let's have an example to better understand this. So let's say you have x minus 2 times the quantity of x plus 2. So notice that the first terms are the same. Second terms are the same except that it's a minus and a plus. So what you need to do, get the square of the first term. So just focus on the first binomial so that it's easier for you to understand. Focus on the first binomial. First term, get its square. Always a minus. And then get the square of the second term. So that would be x squared minus the square of 2 is just a 4. And that would be our final answer. Okay, let's have another one. We have 1 half plus y times the quantity of negative 1 half plus y. The problem now is our form is supposedly a plus b, a minus b. The problem now is the first term here is negative 1 half, not a positive 1 half. So to resolve the issue, just use commutative property. So perhaps you can interchange the 1 half and the y. So y plus 1 half. Then here, instead of putting the negative 1 half first, we interchange the 2. That's okay because commutative property of addition says that it is okay. So that will become y minus 1 half. Now you will notice that the first terms are the same. Second terms are the same except the plus and the minus. So you can use a special product. The product of sum and difference of binomials. So how do we do that? Get the square of the first term. Perhaps focus your attention in the first binomial only. And then always a minus. And then the square of our second term, 1 half. So there's a 2 in here. I just missed that out. So that would be y squared minus the square of 1 half is 1 half times 1 half. Numerator times numerator, denominator times denominator. So 4. So 1/4. So that's our final answer. Y squared minus 1/4. Now let's proceed to another example. So C, the quantity of 4w plus 5 times the quantity of 4w minus 5. So notice that 4w are the same. 5 and 5e are the same as well, except the plus and the minus between the terms. So that means you can use our special product of sum and difference of binomial. So that's a plus b. This is a minus b. So the shortcut again is get the square of the first term, 4w, and then always minus, then the square of our b, or our last term. So 4w times 4w is just 16w squared. The square of 5 is 25. And that's our final answer. So why is it that we say that this is the difference of two squares? Because at the first place, it's always a minus. So that's why difference. Two squares because the first term must be a perfect square. So that's 4w times 4w. So that's a perfect square. The second term is also a perfect square. 5 times 5, 25. So that's why it's so called as difference of two squares. Okay, let's try to find the product of 28 times 32 in a short period of time. So we can actually use a special product to easily multiply 28 and 32. So you can think of it as 30 minus 2 because 30 minus 2 is just 28. Using the same digits, 3 and 2, 30 plus 2, you will get the second digit, 32. So, first terms are the same, second terms are the same. They differ only with minus and plus in the middle. So, you can use the special product of sum and difference of binomial. So, get the square of the first term or the a, because this is our a. Get the, always minus by the way, and then get the square of our b, or the second term. So 2 squared. 30 squared is 900. 2 squared is 4. Then 900 minus 4 is 896. And that's our answer. Okay, let's try last one. So 55 times 45. So you can think of 50 and 5 because 50 plus 5 is 55. Using the same digits because that's our goal to apply the special product here that we are currently using. The A is 50, the B is 5, but instead of adding, we subtract. Because 50 minus 5, it will give you 45. So you can use a special product so that you can get the product of 55 and 45 in a short period of time. So you get the square of A, which is 50, so 50 squared. Always a minus. Then the square of our B, which is 5. So 50 squared is 2,500. 5 squared is 25. And 2,500 minus 25, it's 2,475. That's our final answer.